We're looking at some Python programming, and in the previous video we were doing a little bit of gambling there at the roulette wheel, running a simulation. So about on the same lines, we're going to look at something similar, and that is a lottery that I play every once in a while. And so let's go ahead and bring that up. So this is we've got it's called the natural state jackpot up to 275,000. And what we're going to do here is we're going to run a simulation of picking some numbers, and these particular numbers here are going to be 1 through 39. 1 through 39. Okay. And so we're going to run a simulation picking some random numbers 1 through 39. Of course, these numbers can't repeat, right? So as you can see, a 3 was picked, an 8 was picked, a 23, 24, and 28. Now I'm sure this wasn't the actual order that the numbers were picked in, but what they do here is they just put it in numerical order from smallest to largest. And in our program, that's what we're going to actually be doing too. All right. And so what we'll do is we'll randomly select 1 through 39. We'll select 5 balls or 5 numbers, I guess you could say, and then we'll store that. And then what we'll do is select as though we were going into the convenience store and having the machine do what's called a random pick, and that is we'll let the machine randomly select. Right, we'll let the machine randomly select, and we'll look at the number of times, for example, that eventually the where we actually have our random selection is actually equal to the numbers that actually come up from the machine. Now that picture, and I don't exactly know for the natural state what that machine actually looks like, but I'm sure it's something like this. It's like a big ball here with a bunch of balls in it, and then these balls fall out. They'll pick 5 balls will fall out. Is this 5? Yeah, 5 balls will fall out, and then that will be our random selection. Now this particular one here actually looks like the Powerball because I see a 49 come up. But in the one we're going to do, it's only 1 through 39 actually. Okay, so let's go ahead and bring up a few things here, like for example, let's go ahead and bring up the editor and start to write this. Now this script is actually not that long at all. It's actually fairly short like the other ones. It just goes to show you it doesn't take too many lines of code to actually do something pretty neat. All right. Okay, so we're going to go ahead and sign 0 to C. That'll probably be something that'll keep up with the counting. And we got this the while loop here. We're going to set this to true. Okay, so in other words, it's going to continue to loop until a particular condition is met, and then it will break. All right, it's going to break. Okay, so we'll let int sub 1, capital N sub 1, be we will let that be the random. Let's see, range. We'll pretend this is the machine at the state where the balls are coming out of the big machine. Right, like I think I showed that picture there. Okay, like this here. All right, we'll let int sub 1 be that. Now let's go ahead and explain this real quick. So we haven't used the sample method for the random module here, and what this does is it's going to randomly select a number between 1 and 40 inclusively, and it's going to actually pick 5 of them. Okay, so sample means that there's not going to be any numbers that repeat. In other words, you couldn't get a 1, 2, and a 10, and then a 1 again. All right. And of course, order doesn't matter. This is not a permutation. This is what's called a combination. Okay, so order doesn't matter. In other words, if I got 1, 2, 3, 4, 5, let's say came up, it wouldn't matter if it was 5, 4, 3, 2, 1. You see, so those are actually both equal. Okay, so this is a random pick between 1 and 40 inclusively, and we're going to pick 5 numbers, and order doesn't matter. We call that a combination. Okay, so that's the machine at the state capitol, and of course we walked into the convenience store and asked for a random selection from the let the computer go ahead and just go ahead. We don't want to fill out any forms or anything, and let the computer just do the random selection for us. Now, one thing about the range here is, I don't know if I'm not sure if I've mentioned this or used this yet, but in the range, okay, so this is going to generate a set of numbers 1 through 39. So remember, our balls are 1 through 39, and the reason there's a 40 here is because it won't take the this actual endpoint here, but it'll be -1. Right, so this is really going to generate 1 through 39, but we put 40 here. I don't know why they do that, but they do. All right. Okay, so we have generated our two numbers. Now, what we're going to want to do here is we're going to compare both of these together. All right, and so what we'll do is we will sort them in numerical order. We're going to sort those in numerical order, and we'll use the sort method. Right, and what this will do is that'll go ahead and sort this in numerical order, and then we'll sort the numbers that we got from the convenience store. Right, and of course we'll need to keep up with the count on this, how many times this is happening. So we'll do that. Whoops. All right. Okay. So here it is. If ints of 1, right, that's at the Capitol or wherever they do the drawing, is equal to, in other words, if the Powerball number that's picked by the big machine is equal to the one that we got at the convenience store, well, then it's just time to retire, right? Actually, it'll be a miracle if that happens, I promise. A complete miracle. So if that actually happens, right, let's go ahead and then break the program, and then we'll print off. Let's see, what are we going to print off? Let's go ahead and print off the actual number, the lottery number that we won, because we'll want to definitely frame that, right? And then we'll skip to a new line, and then let's see, what could we say? Well, I don't know, the number of trials. So we'll consider that a trial every time we buy a lottery ticket, and then compare it with the actual winning number. Okay, or the number that actually comes up on the machine. So we'll call that a trial. So the number of trials is, and then C is right. So the number of times this actually occurs. How many times it's going to occur before this thing is going to break. And I don't know, is it going to actually count the last time? Okay, they're both equal. Yeah, I guess so. Alright, let's go ahead and run this. Now, I'll just say that it's probably going to take a minute or so. And of course, we've always got that issue. That's okay, because the program's still running. We hadn't missed anything. Okay, so this may take a while. Yep. So we'll be patient here. So anyway, so I've been playing. Oh, there it is. There it is. So this was the actual winning number right here, it looks like. And the number of trials is, ooh my goodness, 377,409. So you would have to have bought 370. So let's say it's $1 for each ticket, which it is. You would have to have bought 377,000 tickets, let's say, right? Or you would have to have spent, no, let's say this. You would have to have spent $377,409 before you actually won your first lottery. Wow, that's crazy. So the lottery had better be up to never mind. So let's run the program again. Let's see. Sometimes I think one time it was 16,000. That was the smallest I have actually ever seen it. Well, here's actually one that's not too bad. 95,000. You would have to have spent $95,000, right? $95,000 before you won your first lottery. So let's actually take a look at that. So this particular one here is up to 275,000. So if you actually won, let's say that the drawing, they're going to do another drawing this evening, and you won 275,000. Well, really, you would want to subtract, right, the 95,000 from the 275,000, and subtract that, and that's really how much you won, because that's how much you lost. Well, you could actually subtract $1 from that because you won on this one. So yeah, you'd have to spend $95,000. You know, that's actually not too bad. But that just goes to show you that we're going to do this again. I've seen up to 3 million. I think you'd had to play it 3 million times. It goes to show you, just keep your money in your wallet and save it and invest it in a different way. Right? I mean, 310,000 is actually kind of fun. So I got pretty disappointed when I looked at this the other night because I had been buying lottery tickets. I mean, so think about it. If you bought a lottery ticket, let's say every day of the week, you know, how many weeks is it going to take to get before you actually win? You know, we're talking 32,000 weeks here. Probably never win, right? 32,000 weeks. Wow. How many years is that? That's terrible. You know, this has been happening to people everywhere in the world, probably. Now, of course, this is small lottery. This is not the Powerball where you have 49 numbers, right? And then I guess a Powerball number or something. So those numbers are going to be a whole lot bigger than this. A whole lot bigger than this. Since there's only 1 through 39. 1 through 39. We'll do this one more time here. I've seen big numbers. We haven't really gotten a big number. These are actually all kind of small numbers. Here's 831,188. That's how many times you would have to have played it before you actually win. Oh my gosh. Keep your money in your wallet, let me tell you. And keep your money in your wallet. Right? Stay home. Anyway, thought that was interesting. I did that one the other day. I ran the script the other day because I was curious because I've been playing this particular one here, which actually starts out I think at 25,000 and then increases 5,000 every time there's not a matching number. So we're going to come back and visit the lottery because and show you how to find collect data from previous drawings and then see what numbers come up the most often, and I kind of keep up with that, and that's interesting because we'll be taking that data and saving it on Notepad, and then we'll be grabbing that data from Notepad and using that in our program. Right. So that's something that we'll be doing coming up here, and I'm not exactly sure, but coming up in the future, right? Okay. And I'll see you. I think this is 16. I've lost track. I'll see you in the next tutorial. I can't remember what we're doing, but all right. See you there. Bye.